So in this session, we are covering electronics and wearable tech. Now, wearable tech is an industry as it stands worth $30 billion US, and in just another 7, it's going to be worth over $100 billion. With massive players like Google and Apple heavily investing in wearable tech, you can be sure that it's going to be transforming our lives in the very near future. Some people use wearable tech just to be more productive on the day-to-day basis, but others are actually using wearable tech to gain superhuman capabilities for themselves that they otherwise couldn't have as normal human beings. So it's going to be an exciting session where we look at not only how to create electronics, but how will electronics create us in the future. Joining me today is Steph Piper from Elke Education. She's an absolute whiz at electronics herself, and she's also incredibly passionate about inspiring other kids to learn this type of tech. So today we're going to explore electronics as well as wearable tech, both the present and the very near future applications of this technology. We're going to learn how to design our very own circuit, and then also how to simulate that circuit to know that it works using free online software. And lastly, we're going to look at how to convert our circuit into a wearable tech item. Specifically, we're going to make our very own light up superhero emblem. So thanks to Diode Magazine and Core Electronics, we have some great prizes we can give away to you just for participating in today's session. So we have a 1-year Diode subscription. We have a Snap Circuits kit that can create up to 100 different circuits in one kit, as well as we have 5 wearable tech kits to give away from Elke Education themselves. So for more details about how to win the daily prizes I've just listed here, or how to win the major prize worth more than $2,100, stay tuned and I'll give you more information later on in the video. So what is wearable tech? Well, if I had to kind of break it down into a really simple definition, it's essentially electronic devices that can be embedded in fabric such as clothes, or accessories such as watches or glasses, or embedded in ourselves using implants to either assist or enhance our capabilities. Now, where wearable tech, or wearables you can refer to as, fits in terms of what technologies, it's kind of a blend between putting a computer on ourselves to gather data and then accessing data on the internet using IoT or Internet of Things type of networks. So in a nutshell, it's basically an ability for us to capture and visualize data specifically for ourselves, measuring exactly what we want depending on what sensors we put in these wearable tech items. So in this next video, I'm going to show you there's some really cool applications of wearable tech, and you can see that the possibilities are really endless and it really is up to our imagination.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. What if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
So this isn't an exhaustive list, but it's kind of a nice way to look at wearables and where they can add value to our lives. I've just got a few photos here. The top left is a jacket that with one press of a button could instantly heat you. So obviously if you're feeling cold or you're out snowboarding or skiing, you could be instantly heated with a press of a button. On the top right, you'll see a pair of glasses with an embedded camera. Now, what's really interesting about these glasses is as they look at words, the camera using machine vision will detect what words is in front of it. It'll then read those words out to obviously the wearer and allow them to read without having the capability of reading. Obviously, if someone had dyslexia and they had trouble reading, these glasses would be perfect. Or even someone that was blind or partially blind could now read and have the capabilities that they otherwise wouldn't have had. The bottom left, you can see that the Defense Force obviously experiments with a lot of wearables. Now, this particular wearable is what you call an exoskeleton, which means someone actually wears it as a bit of a suit. And this one is a high suction pad suit. And this person can scale walls without any need of ropes. That rope you see there is just a safety harness. But essentially, he's just climbing the walls using just his suction pads. On the bottom right, you'll see even magicians use wearables. This wearable is actually called a pyro launcher, and it's a wrist-mounted flame launcher. And obviously, with a click of a button, you can launch flames at things, which makes for a great magician's trick. There's a few other applications. The one on the bottom left here is LED shoes. Now, you've probably seen them before. They're kind of common. And really, you can see that wearable tech doesn't have to be functional. It can really blend with fashion, and that's what we're seeing in that type of application. Also, the Keep bag down the bottom right. That is also a bit of a fashion accessory, but is kind of functional. It has high-speed charging facilities, it has built-in speakers, an LED display, and overall it just has everything you'd want to stay mobile and stay charged when you're roaming the city. On the top right, you'll see glasses displaying useful information, and that's something that we've seen quite a lot in technology, and they're also being used the same way in cars' heads-up displays. And the top right is actually a really interesting one here too. This is skin-embedded electronics, and each of these tattoos do different things. The flame, for example, the electronics will actually change color depending on the temperature of the skin. So you could actually have an animated tattoo, which is actually kind of cool. The middle one here is what you would refer to as an NFC tag, or a near field communication tag. Every time you tap your phone to pay for something or tap your card, that near field communication is what actually happens when you transfer your data to make that bank transaction. So this person actually has that embedded in their skin. They could pay with their arm or even transfer their contact details with someone by tapping the person's phone on their arm. The last one there, the checkers, is a touch screen. So someone could be controlling something or moving something or selecting or typing just on their own skin. Now, what's really interesting is you see that wearable tech and people or humans, the boundary between them is becoming a little bit blurred as people are trying to enhance what they can do. Now that we've seen the incredible applications of some wearable tech, let's take a few steps back to the technology that allows that to happen, electronic circuits. So we're going to touch on a few fundamentals so that we can start designing our circuit right now in this session. So for an electronic circuit to work, we need electrons to move. Now, when they move, that's what we call electricity, or even current flowing through a circuit. But these electrons don't move the way we want. So usually we need a voltage source, such as a power point, or a voltage source, such as a battery, to push these electrons through the wires and back to the other side of the battery. That allows these electrons to flow the way that we need them to power something. That, in a nutshell, is how we need electronics to operate so that they can work for us. There is tons more to understand about electronics, but I don't want to delve into the detail right now in this session just because we don't have the time. but I'm going to let this next video explain just how circuits work.
In an analogy, we liken something to something else so that we can understand it better. In these pictures, we are likening an electric circuit to a water circuit. Just like you need a pump to force the water around the water circuit, you need a voltage source, a cell or a battery, to force the charge around the electric circuit. In our water circuit, we have water filling all the pipes and the pump all the time. In our electric circuit, we have charge filling all the wires and the voltage source all the time. This is whether the charge is flowing or not, whether the water is flowing or not. What the pump does is it moves the water from where it is in the circuit around. It doesn't make water. Similarly, the voltage source, the battery, moves the charge that is already in the wires around from where they are when the circuit is closed. The voltage source doesn't make charge. In our water circuit, we might have a valve or a tap to prevent the flow of water at certain times. Close the tap and now the water cannot flow. The tap offers infinite resistance, so it breaks the circuit. Similarly, we might have a switch in an electric circuit. When the switch is open, then it offers infinite resistance. It breaks the circuit. Charge can no longer flow. There's not a path for it to flow through at that point.
Now that we know a little bit about circuit fundamentals, let's get stuck into this session's activity, which is to design our own circuit. So, the first thing you need to do is get this template or get an A4 piece of paper and write down all of the headings you see on your paper. Now, we're going to design our circuit in 3 stages. The very first stage is to design it on paper using this template or a blank A4 piece of paper. Stage 2 is then to build it and simulate it, and stage 3 is to look at how we could convert our normal circuit into a wearable tech circuit. So stage 1, let's get stuck in. To do this activity, you need a blank A4 piece of paper or this printed template. You'll need 3 different colored pens. Preferably you want black, red, and blue. But if you can't find those colors, that's okay. Just get 3 different colored pens. Also, I'm going to use a pencil and an eraser just to fill in my details. So let's get started. Firstly, let's fill in the details at the top. So I'm going to put my name, my grade, and my postcode. And I'm going to call my circuit the 2 LED superhero circuit. That's because I'm going to use 2 LEDs in my circuit, and later I'm going to show how we can create a wearable superhero amulet. Now, you can do anything that you want on yours. I'm going to show you the fundamentals that I hope you follow along with, but you can do 3 LEDs, you can do 4 LEDs, you can do as many LEDs as you want. The one rule is that we connect the positive side of the battery with the positive side of the LED and the negative side of the battery with the negative side of the LED. So really that's all we need to make sure we're doing. So I'm going to do mine, and I hope you can follow along and do something similar. Now the first step you need to do is to draw the components in, and then we're going to draw wires to it. So I'm going to draw my coin battery in the middle here and just color it in. Now that coin battery you see here on the side is actually drawn to scale, so if you do roughly that same shape, when you get your coin battery, you should be able to just replace it on your sketch here. Now there is a negative side that I'm going to put at the top and a positive side that I'm going to put down the bottom. Now, I'm going to draw 2 LEDs in. You can use as many LEDs as you want, and you can arrange your LEDs however you want across this area. So my LEDs are going to sit here. And one is going to be over here. Now again, I've drawn in my components, and I'm going to draw the positive and the negative sides in. So that is the negative sides. And these are the positive sides. So once you've drawn your components in, and again, you can use more LEDs, you can put them wherever you want in your space here. But after you put them in and you know which one's the negative sides and the positive sides of all your components, simply grab your black pen or any other pen color that you have and connect them. So I'm going to connect my negative side of the battery to my negative side of the LEDs. And the positive side of the LEDs to the positive side of the batteries. Now, if you want, you can label your circuit. For example, we have LEDs here. Maybe that's LED 2 and that's LED 1. And we have our coin battery. So essentially, that is our circuit design. Now we can jump onto Tinkercad and we can simulate it to be sure that it works. So now that we've built our circuit on paper, let's test it, prototype it, and actually simulate it on a software that can tell us if it'll work in real life. So at the moment, I'm on Tinkercad, and Tinkercad has the capability of circuit simulation, and I can't recommend this program enough. It's free and online, and we've actually taught hundreds of kids how to use Tinkercad for testing circuits. But for this session, I want to make it short and sharp, so I won't go into the level of detail that we do in those programs. But to show you that it can be done, I'm going to grab the coin battery and the LEDs, just like our circuit. And I'm just making these LEDs align so that I connect the positive side to the longer leg of each of these LEDs, like so. And the shorter leg of the LEDs go to the negative side of the battery, just like what we've done in our circuit. Now, if I press Start Simulation, I can actually see that these LEDs are actually on. If we connect this circuit as shown here, it will work, which is perfect. It confirms that our paper circuit will actually work. Interestingly enough, it'll tell us how much current's coming through this LED. And at the moment, although it is a little bit high, it doesn't need to be any much more lower. It won't burst the LED at this point. Now, what's also interesting is you can actually look at the component list and get a list of what components you need to buy for this circuit. So once you build the circuit and simulate it and you see the component list and you know what you need to buy, you can simply go to someone like Core Electronics, tell them that you need to buy this stuff, they'll post it to you, and when you get those components, you already know they're going to work because you've simulated them. So now that we've designed our circuits on paper, we've simulated them on Tinkercad to know that those circuits will work, and then we've got the component list, the very last thing we need to do is actually build our circuit. Now, there are a lot of different types of circuits you can build, even just by using this template here. For example, this one here is what you refer to as a paper circuit. Now, it's called a paper circuit because most of the time you will build these circuits on paper, as you see. Now, these two circuits are exactly the same, except that instead of drawing the components, we've actually installed the components. Instead of drawing lines to simulate a connection, we're using copper tape to actually be the connection. The electricity flows in the exact same way. So as we've used here and as we've simulated on Tinkercad, the electrons flow from the positive side of the battery through the positive side of the LED and back to the negative side of the battery. And this happens to both LEDs. Exactly the same as we've drawn here. Now, this is just one example of a circuit. Another type of circuit we could create is what we call a breadboard circuit. Now again, these two circuits are exactly the same. We have a battery and two wires coming from the battery to connect to the LEDs, and then through the other side of the LEDs we're going back to the battery, just like we are doing here. So these two are exactly the same. The reason why a lot of engineers will use breadboards is because it's one of the best prototyping tools for circuitry. You can fit a lot of components in such a small space. It's very compact and the connections are really quite stable, which is a massive benefit compared to this paper circuit here. But today we want to focus on wearable tech. So wearable tech is just another type of circuit. You can embed the electronics not on paper, not in a breadboard, but in fabric. So I've got the one and only Steph Piper from Elke Education to help us see just how you can make a wearable tech circuit.
Hi guys, my name's Steph Piper and today I'll be teaching you how to do a simple wearable technology activity. So what we're going to be making is one of these. So we're going to have a go at making a light up hero badge for you to wear around your neck. What we'll need for this activity today is only a few bits and pieces. So we'll need a pair of scissors, a couple of LEDs, a coin cell battery. Make sure you keep these away from any young kids, and some conductive tape of some kind. So I could use either conductive fabric tape or conductive copper tape for this activity. So let's get started. Okay. So before we go ahead and make our little badge, what we're going to do is draw a quick circuit board diagram to make sure that we know what we're doing. Here we go. So one of the things I really like about making circuits is that it's always got to be a circle, which is why it's called a circuit, so that we know that when we're making our design, it's always got to start at a positive end of the battery, and it's got to loop around and come back to the negative side of the battery. And today we'll be using our coin cell battery, which is a little circle. We're going to put that up here. We've also got a couple of LEDs as well. They're going to make sure that we have something that lights up. And so LEDs have polarity associated with them, which means that you can only put them one way. The electricity is only going to flow through the long leg, through the LED and out of the short leg. And that's how it lights up. If we have it the other way around, the LED won't turn on. So we've got to make sure that we get that right. So we're going to put in our LED here, where the LED long leg is at the positive side, and here is the bulb. And there's our short leg coming out. If we wanted to add more LEDs, we could actually do that by adding on more like this. And that would be called adding the LEDs in parallel, which means that when it's powered up, all of these LEDs will actually receive the same amount of power. And so you won't have one that's brighter than the other, which is pretty great. So that's the design that we'll be using today. So let's get started. So here's our badge design that we've already made, and we'll be making our circuit on the back of this so that the light will shine through the back, and when you're wearing it, it should look like you're lighting up. Okay, so let's put this down here. Okay, we're also going to take out our little coin cell battery out of its packaging, ready to go. Please do make sure that you keep these away from any young kids that you have, because these can be a swallowing hazard. There we go. Okay, and we'll go ahead and we'll cut ourselves a couple of strips of conductive fabric tape to use. Okay, there we go. So these are our little LEDs that we are working with today. I'm just going to bend their legs back to original. So earlier I was making sure that you guys knew that the LEDs, they have polarity. And so as you can see in this LED, one leg is slightly longer than the other leg. And that long leg is our positive side. And so on our battery here, you can see that there's a little tiny plus sign on this shiny battery here. On that side of the battery is the positive side, and on the opposite side is the negative side. So that's how our circuit's going to come together today. We need to make sure that we match up our positive with our long leg and our negative with our short leg. And that's what we're going to do next. Okay, so we're going to bend these legs back into an open position to make them easy to tape down. And we are going to go ahead and lay down some of these strips of conductive fabric tape. So as I was saying, you could use copper tape if you wanted to here, but I really do like the conductive fabric tape. It's quite flexible, which means that if you do actually want to wear it as part of a project, it will bend and flex properly with the fabric. It's really nice to use. Okay, so we're going to lay down our fabric tape directly onto the battery there to make a nice connection. And then we are going to just lay down the tape there, and I'm just going to do a little bit of a bend in the tape to make sure it goes in a straight direction down the badge. Okay, looks pretty good. We'll cut this little bit of tape off here, and then we'll go ahead and we'll do the other side as well. Okay, there we go. We've got a couple of strips of the conductive fabric tape down. So at this point now, we can do a little bit of a test and see if our LED will light up in place. There we go. We've got one LED lighting up. Let's see if we can do two LEDs. There we go. So it might not be powerful to do two at the same time, but there you go. They don't even need to be taped down for them to start working and show you that the circuit is going to function. So we're going to go ahead and use our red LED for this one. And the last thing we want to do here is we want to tape down those LED legs onto the back of this badge to make sure it's nicely secured in place with a nice strong connection. Okay, there we go. And the other side. Beautiful. Okay. So there's our little light up battery circuit. So now when we turn this over, we can see that it lights up through the back here, which is pretty cool. So you'll actually be able to wear this as a necklace and have it light up and show people that you can do wearable technology. So this is quite a simple activity, but you can actually do some pretty nice, more high-end projects using these same core techniques. So this is one of my favorite higher-end projects that I've done with wearable technology. So this is a little hero band, and let's have a bit of a closer look at it here. So just as before, we've used two rails of conductive fabric tape all the way down, which makes it easy for us to put all of our positives on one side and all of our negatives on the other side. We've also used conductive thread as well to secure our parts into this band to make sure it's nice and strong and durable if we do want to wear it quite a lot. And at the end here, we've got our little battery holder, and we also have a couple of these clips as well. And what's cool is that you can actually use these clips as a switch in your circuit, so that when you've got a second set of clips on the other side, when you join these on to each other, it will actually complete the circuit. So the circuit will make a circle and it will light up the parts, just like that. There you go. So it's a pretty cool little design, this one. And if you do want to do an activity like this, I have a circuit board here that is pretty nice and conveniently designed to do activities like this, and you can test it just by pressing the button here. Wearable technology is a super exciting space, and we're seeing some pretty cool tech come out where you might have in the future a jacket that might warm up for you in the morning when it's a cold day, shoe soles that might warm up, all kinds of awesome tech that we'll hopefully be building in the future. But that's it for today's activity. Thanks so much for watching.
Now onto the prize giveaway. Now, before I start this, I just want to say a huge thank you to Diode and Core Electronics for being the major sponsors of this event and giving us such awesome prizes to give away. Now, the prizes are on offer are just listed above me, and we're going to pick 5 random people from all the people who submit for today's activities, and this will happen each day. Now, of those 5 winners, the very first drawn student will get one of everything listed here. The 4 other winners will get one of this prize here for the 4 remaining prizes of this one. Now, how do you submit? Well, it's quite simple. The first thing is follow along with today's activities and take a photo of your work. Make sure in that photo you have the details such as your name, your grade, and your postcode so we can see who's actually submitting their design for this competition. Step 2 is to share that photo with us. The easiest way to do that would be to post it in the Facebook comments below this video, or if you want to email it to us, feel free to do so. Our email address is info@integratedSTEM.com.au. If you are emailing it to us, please be sure to use the heading of the session. Now, the heading of the session is above on this slide at the very top. So just use that in the subject box of your email. Lastly, be sure that you have liked our Facebook page so that you can see the announcement of the winners. Now, if you need to find our Facebook page, you can search us using the @integratedSTEM.com.au on Facebook, and you should find us. Very lastly, be sure that you get your entries in before they close. The closing dates are here now, and then the winners will be announced the following day at 5 p.m. For the major prize giveaway, you could win over $2,100 worth of prizes. For yourself, you could win a DJI drone, as well as a 2-week 3D printing program with us. And you could win exclusively for your school, our Machine Vision Ag Tech workshop. Now, registrations do close on August 28 at 1 p.m. and the winner will be drawn on the same day at 5 p.m. So to register, simply go to this website link here. It'll probably take you less than a minute to do so. On the website, there's 2 ways you can submit your entry. All the details are on the website. If you do both, you double your chances and you get 2 entries. I hope you enjoyed learning about electronics today and designing your own circuit, and I hope you can envision the future that we all have through things like wearable tech. Feel free to come back to this video and actually design the circuit using the conductive tape, the LEDs, and the battery for the paper circuit that I showed you an example of. You can come back here with those components and just copy that circuit and create it for yourself. Now, if you did find value of this video, please may I ask you to share it with your friends, either through Facebook or sharing the website link, or just telling them that this session was valuable for your child and maybe it would be valuable for theirs. It would really help us get to be able to inspire more kids in technology. Now, if you do want to develop skills in electronics, please feel free to go to our website. We have tons of programs where we teach electronics and go into the depth of designing circuits in breadboards even, simulating circuits on Tinkercad, and just the overall design of a circuit. There's so much more to learn with electronics. Really, we've just scratched the surface. So again, thank you for tuning in to today's session, and we'll see you in the next one.